So we're getting off today. Welcome everybody to our, 64th webinar. Yes, it's the honor for you, David. Thank you for being here and stepping in with this topic. Regular expression, as I said, I'm not an expert on it. You challenged me, but yes, I've been using this for a long while, but only for specific cases, and then I don't use it for a long time. I'm really interested in what you're going to show. Welcome, David. I'll leave the rest of the introduction to you. For everybody out here, good afternoon. For most of you, probably a couple good morning, maybe good late evening. Most of you know our housekeeping rules. Your microphone is muted. Feel free to step in, but then you have to use the question window. Post your question there. Me, Luc van Vugt, again, your moderator, will pick it up. And as agreed, I will step in with the questions to pose to David once it makes sense, or maybe if it's too detached from where he's at the moment, I'll pose it at the end and the specific Q&A session. As always, this will be recorded. We passed the 900 subscribers. Let's see how we can get it moved to 1,000. Yeah, I'll do my best to get the recording process this evening. I'll make my notes on the index, which I'm always adding. That's always taking the most work. So that's why last time Kristen's webinar took almost a week to get it done in a busy week to find time to get everything recorded, or let's say noted down as the index. As you also know our newsletter, be welcome to subscribe if you haven't yet, or tell it to your colleagues or friends to use it also. Probably this week, well, maybe next week, I will send out a new one. I'm working on 2 new webinars. One remaining, by the way, for the 3rd of April on the program we already had set up a couple of months ago. Then we'll have finally the session by Christoph, who fell ill in January and couldn't step in at that time. And yes, this was the first available date. So on the 3rd of April, he will talk about system app and specific features in the system app that you might not know of. I know he pointed out a couple of that I thought, well, yes, good to know. So be welcome to subscribe to this one, of course, and to be attending this webinar series in 2 weeks time again. And before I'm going to hand off over to you, I'm always calling up everybody. Do you have a topic? Do you want to be a speaker? Please step in and do so. I'm always trying to make the threshold as low as possible. I know there have been quite some MVPs on the show this year, but that's not the bar that I'm setting as such. It's just the topics that were, I think, worth sharing. So feel free to step in. And yes, as a last one, before I'm going to hand off over to you, David, thanks for enough again being our sponsor, enabling the webinars. So we're going to make a switch. I'm going to make you presenter, David, and share your screen. Yeah, I do see your screen. I don't know.
Wait.
And I do hear your voice. So
yes,
you're set. Welcome and have fun.
Yeah, thank you, Luc, and thanks for having me. Yeah, my name is David Feldhoff, and I would like to tell you a little bit about regular expressions, and would like to look a little bit into the features of it. Let's have a short look to the agenda. First, I would like to introduce myself, and then I would like to look into what regular expressions are, how they are constructed, and then we will look into the building blocks. This will be the main part of the presentation. And afterwards, the last point will be that we are talking about regular expression in different programs. Of course, I assume that you are mostly here for using it in VSCode or also using it in AL, but nevertheless, I will give you a very quick glimpse into how we can use it in different programs as well. About me, I am David Feldhoff, 28 years old or young, whatever you want. I am living in Germany near Münster. since last year happily married. I have 2 brothers, a younger and an older one. And yeah, if you simply would like to have a chat with me, I like various kinds of sports like snowboarding, mountain biking, going out for a run, or riding motorcycle, if you call that a sport. Besides that, I used to play handball or football, but due to an injury, don't do that anymore in a club. Nevertheless, still fun for me talking and talking about it or playing a bit hobby-wise. Great. Let's look into what regular expressions are and what we can do with them or what they are about. It's mostly about searching text. So of course, you know all search and replace functionality, but there we are always searching hard-coded text. With regular expressions, we can search for patterns instead. And so we can, for example, not simply search for hello world or hello Luc, but we could say hello followed and then that the name is followed. Furthermore, we can extract blocks of the pattern of it so that we, for example, if we stay with the example before, we could extract the name so that we know which person we are greeting. With the blocks that we can extract, we can also use them in a replace case. And here as well, we cannot simply replace it with a hard-coded value. Instead, we can refer here back to the blocks that we extracted and use them. So we can make powerful search and replace scenarios here. And last but not least, it is not tied to a specific language or so not tied to AL or something like that. It is usable in many places and tools. And yes, that's what I want to show you later as well. What is my goal today? I will go through various features and functionalities just for you to see what's possible. It might be that at some point I'm maybe a bit too fast or whatever. Of course, I would like to know that just for me to get a feeling. Yeah, I would like to show what's possible so that you can afterwards use it in your own scenarios. And I think if we want to master regular expressions, we simply have to practice it. And I will show you a cheat sheet where you could look up things. I think it is simply important to know what is possible, to know that you can solve it with regular expressions and therefore start practicing it. Great. How are regular expressions constructed? What are the building blocks of it? First of all, there's the pattern. I think that is the most complex one, and here are nearly all features in it that I will show today. Nevertheless, a regular expression consists of 2 things: the pattern combined with the flex, or also called the options of that regular expression. And these 2 things are combined and compiled and executed by the regular expression engine. And there I will show as well what it makes, what's the difference if we use different regular expression engines. At first, I would like to go into the patterns topic and want to show you some basic tokens that we can use. For the ones that already have joined my session at Tech Days or Directions last year, this will be a short repetition, but I hope nevertheless you will stick with me, because after these, let's say 10 minutes, I will show further examples. But for now, I think it is important to have, to get started and to get everyone on the same page. Great, so I've opened here the base app. And on the right side, you will see my presentation slide for the next 10 minutes. And you'll see that I've opened the table customer and table sales line. And what I'm trying to do now is that I'm matching all table or all object definitions. So I know that there's a table followed by an ID, followed by a name. And if we are going in VSCode and start searching table, then this is working. And if I click here on use regular expression, you see that the search results are exactly the same. This is because until now I did not use any special token. The first token that we will learn today from regular expressions is the dot, which is simply a wildcard character. And if I'm pressing the dot key now, you see that I'm matching the 1 or the 3 of that ID, but I'm also matching, for example, an equal sign or the A of the end word here. That is, of course, not what we really want, because we know we want to match an ID, and therefore we do have character classes in VSCode, in regular expressions, and we define character classes by using square brackets. And inside these character classes, we can then define values or characters that are allowed for the next character. So I could say ABC, that would allow only these 3 characters, but I could also define multiple ranges. And I can even negate the character class by putting a caret at the beginning of that character class, and then it means it allows each character except uppercase A to Z. So obviously in our case it is we are only allowing the values 0 to 9. And now we see, if we're looking at the search results, that all these editable equals something are not matched anymore, because now we are only matching the first digit. Another thing to character classes I could say is that we have, for recurring character classes, some shortcuts. For example, the \d is a shortcut for 0 to 9, so that you don't have to type it again and again. Other shortcuts are \w, which stands for any word character. There we do have the uppercase and lowercase A to Z, also 0 to 9, and also the underscore. Okay, so if I use here instead \d, I'm now having the same results as before, but just I used the shortcut for it. And now we know that an ID is at least 1 digit long, but it may have multiple ones. So we want to somehow tell the regular expression engine that it should match multiple digits. And that's what quantifiers are for. And there we have 4 alternatives. The first one is the question mark, which is, specifies that this character should be there 1 or 0 times. The star means 0 to unlimited times, the plus 1 to unlimited times. And if we want to be even more precise, we can specify in curly brackets the min and max value. Both are inclusive. So for example, 2, means 2 or more times, or 4 means up to 4 times. If we specify that, or add that to the \d, it means that we have 1 to 4 times, 1 to unlimited times a digit, and you see it is matching pretty good. And as we just learned that \w stands for any word character, we can also try to match words. And we see that for the table customer, we also have a valid regular expression. Great. But we only have 148 results. That is, of course, not each table in the base app. And you also already can see that the sales line is not matched. So, and one further thing that we do see is that the obsolete reason is also matched. To get rid of this and these obsolete reasons, we can specify anchors in regular expressions. With an anchor, we can say that by putting the caret at the beginning of the regular expression, that the line has to start with these matches. And table something, this one of course starts with a, the line starts with that match, and here it doesn't. So if I put it at the beginning, we see that all the other search results are not matched anymore. Okay, but now we are coming to the tables that we still do not match, which are, for example, the sales line table. And we can now, of course, try to simply say, okay, we have this a sales line starts with a quote, and then we have either a word character or a space is also valid, but then you notice we also have tables like country/region or customer.ledger entry or ship -2 address, and even then I don't know if I've matched all the cases. So we shouldn't use a whitelist approach in this case. Better would be to use a blacklist approach, so that I could say there's a quote, and then we have, by adding the caret at the beginning of that character class, we say each character is allowed which is not a quote multiple times, and then we have to close afterwards again with a quote. So let's do that. And now we see that we are matching the sales line already, as well as, for example, account.scheduled something. So this looks already pretty good. But now we are, of course, not matching the table 18 customer anymore. So we have an alternative here. We have either this regular expression pattern or the other one. And we can combine both of them by using the pipe. So we have simply, this is the one that matches the customer, and this is the one that that matches all table names that have quotes around it. And if I copy paste them here, you'll see that we are matching both table names, and based on the results, 1,500 tables that could approximately match. Great. But of course, we do have now a repetition here. And we can get around this one by using groups. And we do that by using normal parentheses. And then the or inside that parenthesis does only have effect to the things that are inside that group. So we could only once write table \d and then say either we want to have a name, or we are allowing special characters, but then they have to be surrounded by quotes. So if I take this one, then we have now a good regular expression which matches all the tables. Great. Just as a recap, what we learned so far. So we learned the dot, which stands for a wildcard character. Then we learned character classes, so that we only allow digits in this case. Then we learned that for some character classes we do have shortcuts, for example, the \d, which stands for any digit. Then we learned the quantifiers by specifying the plus behind it. It means this digit in this case, or word, will be there or should be there 1 to unlimited times. Then we learned that we can add the caret at the beginning, that it means that the match has to start, that the line has to start there. And then we learned the alternative, so the or statement, by using pipe for it. And then we learned that we can use parentheses to not repeat everything or again and again the whole regular expression. So we simply can reuse the first part, and only for the naming we can have an alternative. That should be it for the basic tokens, and that was a part that I also showed on tech days or directions, but up until now we are moving again into new stuff. And this will start with flags and what flags are. So with flex, we can modify the pattern that we just used or created. And some typical flex, there are much more flex, but I just want to name a few. So for example, we could specify the I flag, which means that the pattern is then insensitive. So we do have in case insensitive match, or the G means that we are making a global search. Otherwise, the pattern or we only would return the first match. But if we are adding the G to it, we are returning all matches that we get. M flag would, for example, mean that it is treated as a multi-line pattern, and then the anchors that we just learned, so the caret and the dollar sign, they would match each line and not just the whole text. And last but not least, the S flag means that it is a single line. And I think I haven't mentioned it, but the dot, which is a wildcard character, matches everything except a new line. But if we also specify this S flag, then the dot matches even the new line character. Great. I can afterwards show you a few more of them and where to specify them. But for you to know, it is not just the pattern that we specify, we also specify flags. And yeah, that's it then. Now I'm moving back to patterns to show you a bit more advanced scenarios. And for doing that, I am going to regex101.com. That's the site that I'm usually using. I know there are quite much other websites for regular expression evaluation, but I do like this one pretty much. And yeah, see no reason to switch. I will show you once how it looks like. So this is Regex 101, and I can here specify my pattern. And at the right side, you see that we have here the regex options or regex flags. So even here on the side, it is named differently, but options and flags are basically the same. And you see that here we have as well a few more flags that I didn't mention so far. For example, the extended one or Unicode or whatever. So with that, we can change or modify the whole pattern. Furthermore, we can see here the explanation part where this website helps us understanding what the regular expression does. We also see the match information, and here we do have a cheat sheet. For example, what I just explained earlier. This one is a single character of ABC, so we specify a character class for it. Here we can negate it. We can specify a range. We can use any single character by using the dot. The alternate, or simply the or, how I called it, is used by is done by the pipe. And here you see also the white space character, which I explained, the \s. So yeah, this is simply a cheat sheet, and you can even search for it here in the search bar. If you are not really familiar again what it was and how it was written, you can search for it and then put it to your pattern. Great. The first advanced scenario that I would like to show is that quantifiers are by default greedy. What does that mean and what can we do about it is that we can make them lazy as well by adding a question mark to it. And I will now show you in a demo what it does. So here we have our test string. Luc's first words on his first birthday have been test automation. And as you see, the regular expression pattern is a wildcard, 0 to multiple times. And then we say that we have to have this word first. And after which we have, again, 0 to unlimited times, a wildcard character. What is maybe surprising is that it matches the second first, not the first one. So it says that the second first is part of the capturing group here. And what I just said, we have an explanation here on Regex 101, so it explains you this is the first capturing group. The star means that it is greedy, as we can see here. And I will show you in the Regex debugger here at the bottom left corner. We can see how the Regex engine evaluates the regular expression. I will do that once with you together. So the first part that is evaluated is that wildcard character 0 to unlimited times. And he's directly matching the whole content. So that means that it is greedy. It takes as much as it can. And then it notices, I need to match the word first. That doesn't fit, and I'm going one step back. And that does it now again and again until it reaches the word first or first birthday, and then it is able to go ahead. So now it matches first. And now here with the last step, it matches again the whole rest of the text, and it is happy. So that is why, and we took, by the way, 90 steps to evaluate that pattern. Now we can make this quantifier lazy by adding a question mark to it. You directly see here now also in the explanation that it is now lazy and that it only takes as few times as possible. And now we are also matching this first word. If we go now to the Regex debugger, we see that the first try is that it tries that the plus does not match anything because it means 0 to unlimited times. That is not working. So it takes the first character, the second character, and so on. Then it is happy. And so now only with 20 steps, we passed the whole, the whole pattern. So you see here, we can increase the performance of regular expressions simply if we know a little bit about the text that is coming in. Then it might be clever to use a lazy evaluation, or maybe you are confused why he takes this as a second, the second word instead of the first one. It might be because you used a greedy quantifier. Great. Another thing is that groups are capturing by default. What does that mean? The content of each group that we are having. So we are defining groups by using normal parentheses to remember. And we can then reference these content in a replace part. And then $1 and $2 refers to the first or second or whatever capturing group. And a special one is the $0, because this one refers to the whole match. So if I'm now going to the substitution here, we can see we also have this substitution thingy here at the bottom. And I changed a little bit as well the pattern, so that I said any wildcard character followed by a word, and then birthday have been something. So that I'm saying Luc's first words on his first birthday. This is part of the first capturing group. Have been, and then all the rest of the text, which is test automation. And then you can see in the substitution by specifying $0, it returns the whole first text. So that is part of the $0. And then I'm writing down which birthday has it been. His first. So here with $1, I'm referring to the content of that first group. And the words were test automation. So here I'm referring to the second group. I think that should be clear. Another thing that we can do now, of course, it takes, on the one hand, it takes some resources to capture everything, but even sometimes we do have lots of groups, and it is a bit hard to understand which group I'm now currently in. Is it the 4th or 7th or 8th groups that I'm currently capturing? So you can specify with question mark followed by a colon. You can make the group non-capturing. You see here in the explanation now as well we have here a first capturing group, and the second one is a non-capturing group. And now we also do not have here group 2 anymore. That's why he's complaining here that the group 2 does not exist at all. So yeah, that's what we can do as well to yeah, say some groups that they should be non-capturing. The third thing are look ahead and look behinds. What does that mean? Let's say we want to find out who is organizing the party, because Luc's first words have been test automation. One idea is, of course, to say I want to have this word character one or multiple times and then organize as a party. But if I just want to get the name matched, then I would afterwards have to say, okay, I have now a match here, and then I have to replace organize as a party of that result. So better would be if I really simply get the name returned. And we can do that by specifying a look ahead. I'm using this cheat sheet now so that you can see the usage of that as well. So it's simply in parentheses, equal sign followed, question mark followed by the equal sign. So let's do that. Great. So now we are only matching the word one or multiple times, a word character one or multiple times, if after that the text organizes a party is following. And then we have the person that is organizing it. That is a positive look ahead. You see a negative one would be simply replacing the equal sign with an exclamation mark. We can do that as well once. And now you see something that you maybe haven't expected as well. And that is because, of course, all the other words, I think that was as we expected. But here, the Luc, the L, the first two characters are valid because they are not followed by organize as a party. I would like to, on the fly, introduce another thing, which is called a word boundary. So we say, after this one, after that word, there has to be a word boundary. So it has to either be a space or a dot or whatever. And this word boundary is not, wrapping some character or something like that. It says simply after that word character, there has to be a word boundary, and then there has to be the words organized as a party. And now the whole word or name, in this case, Luc, isn't matching anymore. That was the look ahead. Look behind is quite similar. Here we have the statement that Luc has something to celebrate and I am the one that has to organize a party. And I would like to find out if that mail text or whatever is coming in, if that is a valid one. And I could say this is the syntax of a look behind. And then I can say it is only valid if Luc is the organizer. So as we can see, the regular expression does not match. So we see this text does not make sense. If Luc would be the organizer, of course, that is valid. And if Luc is organizing my party, that is, of course, also valid. So that is a positive look behind. The same thing is done again by, so a negative look behind would be as well simply replacing the equal sign with a question mark. And then I could say it is fine for me if anyone is organizing or is celebrating something, as long as I am not the one that has to organize it. So that is look aheads and look behinds. Next advanced scenario, backreferencing. So here we do have, so Luc, first words, blah, blah, blah. And then I make a backreferencing with \1, and that means it refers to the first capturing group. So if here would be written David organizes a party, that's still not valid. So this means whoever is celebrating a party, he has to organize it. So yeah, Luc organizes his own party, and if I am organizing mine, then I have to be, so yeah, always celebrator and organizer have to be the same. So here we are referencing to the first capturing group. Great. And this is the last advanced scenario that I would like to show you. It's the name groups. So it might be a little bit, yeah, hard to understand what is, I will take this one away, to see afterwards, yeah, I do have group 1 or group 2, but who is who? And I can make it a little bit more, yeah, that it speaks more on its own, and therefore I can put question mark followed by these, yeah, don't know how they are called, but yeah, between these tokens, and then I could give that group a name. So this is the one, the celebrator. And you see now that we do not have a group 1, but we instead have a group celebrator. And of course, this one is then the organizer. So now the results are a little bit more speaking or meaningful. And yeah, I used them quite much, but of course, so because the result is more, we can understand it better. But the downside, of course, is that we have quite much characters in the pattern, which is not that easy to read anyway. Yeah, I think you have to decide on your own if it's great or not. But yeah, might be a good help.
May I step in, David? I do.
Yeah.
Already. So yeah. Then, with the group naming, is that a variable name that you can then reference from your code? Then, if this is the organizer, yeah.
Yeah, yeah, okay. Exactly. I can show it afterwards. In I have an example for it. Great. But you can even use it here in that pattern as well, because we just had backreferencing where we refer to the first capturing group, and that's basically we can do the same here, and therefore we are not specifying \1 as we did for referencing to to a capturing group. Instead, it is the K. And then we say this one refers to the celebrator group. Of course, the text is now not matching as I have to organize my own party, but now it says the celebrator's first words, blah, 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 and the celebrator has to organize their own party. So therefore, it is, as you said, like a variable that we can then refer to.
Clear.
Great. Yes, that's what I already also showed here. We can use backreferencing with \k followed by the name of that group that we want to refer to. And yeah, also, as said, I want to show you what's possible with regular expressions. All these things are written down here in the search reference. You simply have to remember, it was something with backreferencing. Come on, or don't. Wasn't it? Maybe bad example. Somewhere here it is written. Was it? This one was it, I think. Yeah, I have to search for it, but you see the scroll bar is not that big. Here at least it's also the named capturing group, and yeah, there's also a reference to that named capturing group. Okay, going back to the presentation. I haven't talked so far about the Regex engine. So I said that the Regex engine is compiling and executing the patterns and flags, but nevertheless, it is important to know that there are multiple Regex engines because not each engine supports each functionality. And therefore, I will once go to Wikipedia, and you see here at the top, the most things that I just showed you are supported by each engine. So for example, the plus quantifier is nearly supported for everything. Negated character class, so that we specify the caret at the beginning. That is also supported. Non-greedy quantifiers, so to make them lazy, that's what's meant here. A shy group, for example, is a non-capturing group. That's what I showed as well. And you see that is basically supported nearly by everything. But nevertheless, a few engines also support recursion or something like this. Or here's a part 2. You see here are much more wet blocks. And yeah, it's just for you to know. To be honest, I don't know which engine VSCode, for example, is using or AL language is using. But just for you to know, if you are pretty sure that your pattern is correct, that you use the correct functionality, then it might also be that simply the Regex engine is not supporting it. Maybe I could give you one example. I could say here in backreferencing, if I take that example once again, I could give it a name, and now I could make a look behind, and now it says it is not supporting because this one is not fixed length. So look behind is usually, it is only working if we have a fixed length constant. But if I'm changing the flavor, here it is called flavor, so it's flavor, Regex engine, it's the same, it means the same. The ECMA script is supporting look behind. So you see, even if the pattern is correct, it might be that it is not supported by your engine. Just want to give it with you. That should be it with that one. And yeah, then I would like to show you shortly in different programs how we can use them. For example, in Notepad++, it's simply a text editor, and even there you can open the search bar and say table. Here I simply used that regular expression I showed earlier, and then I can here say in the search mode that I want to use regular expression. And by the way, this dot matches new line, you know that is simply the S flag, so the single line flag. And these are simply flags that we can specify. And even if I go to the replace, I can here with $0, I can refer to the whole match, and then I make a comment where I just specify the object name. Let's see if it works. Yeah, it works perfectly fine. So even text editors, it is not, what I want to show is it is not something that is bound to a programming language or something like that. And with capturing groups, I have here a simple thing, table 27 sales line. Then I can have a regular expression where I am using these named groups, ID and name, and then I can do object definition minus match and giving the regex with us. And in PowerShell, that is now, you have to know that, but in PowerShell afterwards you have a built-in variable which is called matches, and there I can simply return with ID and name. I can access these groups. And if we execute it once, you see ID is 27 and name is sales line. So here it is much better to use capturing or named capturing groups because it is much more easy to read afterwards. Great. But now I would switch to VSCode and the AL language. You see in VSCode, I showed already in already here that, or did I show it here? No, but what you can see is we have this case, a match case, if it should be case sensitive or not. And so this is the I flag, and yeah, basically that we can't set many more flags here. But yeah, that's it what it is. But if we are programming on our own, we do have in AL a code unit called regex, and there we do have a pattern that we give gives that code unit, but also we can define the regex options or flags, however you call them. And if you want to see a few examples of it, I will go here to the test of that code unit. You can see it is simply a table, and there we can say ignore pattern whitespace, ignore case. Don't even know what this compiled flag means, but there we can specify flags to change that pattern. And then we can work with that or instantiate that pattern. And then with this match, we can find out if it is a match or not. And here with match, we are getting returned a match record of type matches. And then there we can work with that match as well. I think looking at the time, I'm pretty much done. So I would say thank you or vielen Dank for sticking with me. And yeah, you can find me on Twitter or LinkedIn, whatever you feel like. And once again, Luc, thanks for having me. If there are any questions, I would be happy to answer them now.
Well, vielen Dank. Dankeschön, that is better. Thank you very much, David. Yes, loud and clear. There are no questions. I think you, flabbergasted everybody. No, I don't know. They have to tell. If there's somebody having a question to ask to David, feel free to step in. You might make a quick note like, I have a question, then I see that you will going to pose a question, but not anything at the moment. So, and I don't have an additional question either. So I think with many things, and it looks great how you from memory step in and say, oh yeah, now we have this Lookbehind and whatever. It's something you need to practice and you start using. There are some notes in the question window right now. Arthur van der Vondervoort says no question, but thank you for sharing. Inge van Erp says, can you show us how to search for a part of a string? That's a question. And then while you set up to do that, Bert Verbeek says, very great session, very clear. And Inge adds to her question, for example, all tables with entry in it. So just with what you showed, I think I could manage in a way, but for you to show David, so she wants to search into, for example, the VSCode searching in the base app or in my extension, all the tables that have entry in their name.
So I do have, for example, here, I say I want to have at least one character which is not a quote, but it should have the word entry in it, or should end. Currently, I'm saying it should end with the word entry. If I would allow further characters after it, I can make it here as well, and saying there should be or can be. Here I'm using the star that I say 0 to unlimited times. And yeah, now I have all tables, analysis view, payment entry, approval entry, whatsoever. Yeah.
I hope that answered. So I wouldn't have done it this quick, surely not. Probably even did not manage at all. So Inge, I hope he blew you away. Maybe you have an additional question, Inge, that he searched for any table with, I don't know, entry and ledger. I mean, what would that be? If you search for entry, anything with entry, but also ledger entry, that's of course one word. That wouldn't be very interesting, I guess. No. But as she says, thank you. So no follow-up question, I think.
Awesome.
Yeah.
Maybe one last thing which I could share, which was a question I got already a few times right now, which is a bit how would you call it? I will simply show it. It was about they wanted to search for trigger or empty triggers, and if they did it, it was like it should be a trigger, and then I would like to have \n, so in a new line, and then I would like to have a wildcard character or a new line, and then at some point in time there should be the end. And first, what you see is it matches everything. This is, of course, because we are using a greedy quantifier. We can fix that one by putting the question mark behind it. But even then, we do have issues. Like, now I have to find an example for it. Maybe picking one which is a little bit bigger. Come on. Yeah, for example, this one. So he's matching the word end, but is not going to the correct place here, you see?
Yeah.
And yeah, what is then a solution that I would do is putting the caret at the beginning. So we say we have to start at the beginning of the line, and then we are storing the lines or the spaces before it until the trigger is coming. And then we are saying that we want to have a new line followed by exactly the same spaces of the beginning, and then there should be the end, and then we are matching everything. So yeah, and then we can find out the whole procedure, or we can find entirely empty triggers or whatever. So yeah, pretty powerful.
Can you put that in the search string too, that it turns out only to show the empty triggers? Or is that
currently I'm just searching for wildcard trigger /n. Of course, we will then have that. So that should be it. I have to modify it a bit more so that I have the trigger as well, but now I have empty begin ends, and you see we have already 27 of that in the base app.
Yeah.
Yeah.
Okay.
Exactly.
Great. Wow. I saw surely more than I've seen before, so I'm a happy guy, and I reckon Inge, with her question example, is also a happy girl, if I may say so. Well, if nobody has any other question, we're going to shut down, call it a day for today. I'm going to switch to my ending screen just to make that part. So thank you everybody for joining us. Hope to see you again in 2 weeks time on the webinar that Christoph is going to do. Once again, David, thank you very much.
Yeah, and thanks for the feedback from the guys that posted something in the chat. Happy to see that.
Yeah, of course, and it was a valid example. So I'm going to close down. Everybody, thank you very much, and have a good evening, afternoon, night, whatever. See you again. Bye for now.
See you.